Okay, class, this is the last section of Unit 10. This is 10-6, and we're going to talk about geometric probability. We're going to learn to calculate the geometric probabilities and use geometric probability to predict results in real-world situations. And we've already been applying a little bit of this in class already. Okay, geometric probability is used when an experiment has an infinite number of outcomes. In geometric probability, the probability of an event is based on a ratio of geometric measures such as length or area. In every outcome in this sample space is an equally likely chance. The theoretical probability of an event is number of the outcomes over the sample space. Okay, so here's some examples of geometric probability. So if you have a segment here, and we're wanting to know the probability of it landing on segment BC. So you would have the measurement of BC over the sample space, AD, to find that probability. If we have a circle, and we want to know all the points in the circle, that would be 360 degrees, all the points in the shaded region. So you would have to find the measure of that angle. That would be your theoretical probability. And then area, you'd have to find the area of the total sample space, the rectangle, and then the area of the triangle. So your events would be the segment BC, the sector, and the triangle. And your sample space would be AD, the circle, and the rectangle. Okay, so let's apply this. Okay, the point is on RS. Okay, so we want to know the probability of the point on RS. So, the event would be the segment length RS over this sample space, which would be the larger segment PS. So it would be 5 over 7 plus 13 plus 5. Which is going to be 5 over 25, which is 1/5. So the probability of it landing in this section would be 1/5. Okay, the point is not on QR. Okay, so let's first find the probability that it is on QR. So QR is 13, that's the event. The sample space is 25. So this is if it were to land on QR. To find that it would not land on QR, you would take the total probabilities out of 1 and subtract. So that would be 12 out of 25. So the probability of it not landing on QR would be 12 out of 25. Now another way you could do that, class, is to take not QR, which would be the PQ and the RS, and add the 7 and the 5 and put it over the sample space. Okay, the point is on PQ or QR. So it would be the probability of PQ or the probability of QR. Okay, so probability of PQ would be 7 over 25, or means you add. Probability over QR would be 13 over 25. So then the probability of it landing on one of those two segments would be 20 out of 25. And you can simplify and get 4/5. Okay, if you arrive at the signal 40 times, predict about how many times you will have to stop and wait more than 40 seconds. And I need to move up one. I think this is your number 4, so let's do this one first. A pedestrian signal at a crosswalk has the following cycle. Walk 45 seconds and don't walk 70 seconds. Okay, so here's the starting point. This is the walk. This is the don't walk. Okay, so the walk is 45 and the don't walk is 70. Okay. So, where's the question? What is the probability the signal will show walk when you arrive? So let me back that up so you can see it. Walk when you arrive. Okay, so it's the probability of walk. Okay, so the event is the walk, which is 45 seconds, over the total sample space, which is the 45 plus the 70. And we're going to go ahead and change that to your percent. So that is approximately 39%. You will hit the walk on it. Okay, now let's go back to, it was this one here. If you arrive at the signal 40 times, predict how many times you will have to stop and wait more than 40 seconds. Okay, so this one had, this was the walk, 45 seconds. This is piggybacking off the other one. And then you would wait 40 seconds. So this is the stop. And this is the wait. Okay, so it says predict about how many times you will have to stop and wait more than the 40 seconds. Okay, so here you're walking. This is the 40 seconds. So where you have to stop and wait more than this is going to be this segment right here. So it's going to be 30 out of the total, which is 115. Okay, you simplify that, you get 6 over 23. Predict about how many times you will have to stop and wait more than 40 seconds. So if you multiply this by the 40 seconds, so it's more than, it's going to be about 10 times. Move on, we've done that one. And now let's look at this circle here. Okay, you've got a spinner. Use the spinner to find the probability of each event. Okay, so the probability of it landing on yellow, well, the event would be 140. And the sample space would be the whole circle, which is 360. And that would be 7/18 when you simplify. On blue or red, okay, so blue is 52. Red is 60. Over your total sample space. And that's going to be 14 over 45. Not landing on green. Okay, so green is 108 over 360. So not landing on green, you need to take 1 minus the 108 over 360. 1 is the same as 360 over 360. Okay, find the probability that a point chosen randomly inside the rectangle is not inside the triangle, circle, or trapezoid. Okay. So, let's see here. Let's first find the area of the rectangle. This is the sample space, okay? So area of a rectangle is your length times your width. So we have 45 meters times 20 meters. Okay? Then, let me put that right here. So here's our rectangle. Let's find the area of the circle. So our radius is 6. And so here's our circle. Okay, let's do our trapezoid. So let's see. Our trapezoid is your sum of your two bases times your height divided by 2. Your bases are the parallel sides. Your height has to be perpendicular to your bases, so our bases are 3 and 12. Our height is 10, and divide that by 2. So trapezoid is 75. Okay, and then on the triangle, okay, so on the triangle, we'll use 1/2 of the apothem times the perimeter of that triangle. Okay, so our apothem is going to be 6. And then this is 6, this is 3, this is 3. So our perimeter is going to be 18. So our triangle is going to be 54 meters squared. Okay, so we need to add these three up. So when we add those three up, should get 263.1. All right. So probability of landing in one of those three is 263.1 over the sample event, the 900. So the probability of it not landing in those three is going to be 1 minus the 263.1 over 900. And you're going to get approximately that. Okay, guys, I think that's it, and it is. You all have a good one.